Hello viewers, I'll be showing you how to use binomial theorem in expanding this. We know that for a binomial theorem of this format that a plus, let's say solution, we know that a plus b all raised to the power of n will be equal to summation of n, starting from 0, a raised by n minus r b r. So this is the formula we are going to be using to evaluate this. So from our question, if we compare this to this, okay, let's say a plus b all raised by n, x plus 2 all raised to power 5. So if we compare these two, we will know that this is a is x, our b is 2, and our n is 5. So we can now say that a equal to x, b equal to 2, and n equal to 5. So we are going to be using this expansion to solve this. Oh, sorry, before we get here, this would be n combination r a raised by n minus r b r. So that's the formula we are going to be considering in order to solve this problem. And so let's solve it using this formula. This is n combination r. Okay, so we are going to be using the method of combination to solve this problem, and I have shown you how to, in one of my videos, how to express the problem in terms of combination and how to solve it, so you can watch out for the video. So let's solve this. So we are going to have n is 5 for the first term. N is 5, so we have 5 combination r is, what is our r? R is 0. We are starting from 0 down to 5. So a is what? X. So we have x. N is what? Our n is 5 minus our r is 0 for this one because this is r. Dot b is what? 2, and is raised by 0. So we are done with the first one. Plus our n is still 5 combination. Our r now will be 1. Note we start from 0. R will be 1. A is still x raised by n, which is 5, minus r, which is 1. Dot b is 2, and our r is raised by 1, plus we take 5 combination 2, okay, because our r is now 2. Our, okay, x, a here is x raised by n is 5 minus r is 2, and then our b is 2, and 2 is raised by 2, which is r. We continue, we can't, so okay, let's take this plus, we have again 5 combination 3, x raised by 5 minus 3, because our r is 3, dot, which is the same thing as multiplication, 2 raised by 3. Okay, so we have to do it until we have 5 here, since we are considering raised by 5. So we have to do it until we have 5 here. So the next one will be plus 5 combination 4, x raised by 5 minus 4, our b is 2 raised by 4, plus the last one, 5 combination 5 x raised to power 5 minus 5 2 dot 2 raised to power 5. Okay, so we've gotten that, so we have to start calculating. So we can use our calculator to find what 5 combination 0 is. So we have 5, press shift, we come to where combination is 5 combination 0. So 5 combination 0 is 1, 5 combination 0 is 1. So we are going to have 1 here. Then x raised to power 5 minus 0, this will be times x raised to power 5, because 5 minus 0 is 5, and then times 2 raised to power 1. 2 raised to power 0 is 1, that is any number raised to the power of 0 is 1. So 1, so we are done with the first one. We are done with this one now. So we now have to consider this. So 5 combination 1, so we press our calculator again, 5, shift, this is where combination is 5 combination 1, and so 5 combination 1 is 5, so we write 5. Okay, and then this one is x raised to power 5 minus 1, so 5 minus 1 is 4, so this will give us times x raised to power 4 times 2 raised to power 1, this is 2 raised to power 1, this is times, so it will be 2. 2 raised to power 1 is 2. Okay, I think I should put times here for some persons who may not understand. It's times 2 raised to power 1 plus. So we are done with this now. This times. So we are done with this. So we now go to this part. So 5 combination 2. So we say 5 combination 2. So 5 combination 2 here gives us 10. So we have plus 10. Then we have x raised to power 5 minus 2. So that will give us times x raised to power 3, because 5 minus 2 is 3. Times 2 raised to power 2 is 4. So we have times 4. Plus we are done with this now. So we now take this. Okay. So 5 combination 3. So we check 5 combination 3 is still 10. So we have 10. X raised to power 5 minus 2 will give us times x raised to power 2 times, so 2 raised to power 3 here will give us 8. So we continue down here. So we are done with this. So we want to consider this now from here down here. So we have plus, now 5 combination 4. 5 combination 4 is 5. So we have 5 here times x raised to power 5 minus 1 will give us x raised to power 1 times, okay, we can put times here. It's the same thing here, times, for those who may not understand that dot here means multiplication. So 2 raised to power 4, that is 2 times 2 times 2, 8 times 2, 16. So we are done with this now, plus 5 combination 5. So we take 5 combination 5. So that gives us 1. So at this point we are taking here now. Okay, 5 combination 5 is 1. X raised to power 5 minus 5 will give us times x raised to power 0, because 5 minus 5 is 0, times 2 raised to power 5 will give us 32. So we've covered here. So let me erase this so that we continue with the solution. So we continue. So from this point now, we say 1 times 5, 1 times x raised to power 5 times 1 will give us x raised to power 5 plus, we are done with this one now. Now 5 times x raised to power 4 times 2 will give us 10x. We want to take this now to give us 10x raised to power 4. When we say this times this times this, to give us 10x raised to power 4 plus. So we now have to take this now, this down to here. So we have 10 times x raised to power 3 times 4 will give us 40 x raised to power 3 plus. So we now have to take this. 10 times x squared times 8 will give us 80 x raised to power 2. So we now have to take this. 5 times x raised to power 1 times 16 will still give us plus 80 x raised to power 1 is the same thing as x. Then 1 times x raised to power 0, x raised to power 0 is 1, so this is 1 times 1 times 36. Oh no, this should be 32. 2 raised to power 5 is 32, sorry. So 1 times x raised to power 0 is, because x raised to power 0 is 1. So 1 times 1 is 1 times 32 will give us plus 32. So we have plus 32. So this is, yeah. So looking at this, we've been able to expand this, and this is what we have as our answer. So in the expansion of x plus 2 all raised to power 5 will give us this. And note, if you look at it, you see the way the powers are decreasing from x raised to power 5 to x raised to power 2, 3, 2, 1, and then x raised to power 0. So viewers, basically this is how to expand this using binomial expansion. Thank you.